All right, now I broke 8.5 into two videos. The first video was finding the area of a triangle. The second part, this video, is going to be missing dimension. So if you have a triangle and you know the area, and then you look at the picture of the triangle and you can identify the base and you can identify the height, and they make a 90-degree angle, but you'll notice one of those, either the base or the height, is not there. It's missing. It's a variable. So what we're doing today is looking for that missing dimension. So we would start just like we did with the quadrilaterals. We would start by writing the formula. An area of a triangle is always going to be 1/2 times base times height. You also could do base times height divided by 2, or 0.5 times base times height. And I find that I tend to gravitate back to the 1/2 times base times height, but I will do a variety on this video. So first I'm going to plug in everything I know. Instead of the A, I'm going to put the 112 there because that is the area. The 1/2 doesn't change. The base is a 7, and the height is the thing I don't know. Now, in the picture here where they're using W for the height, if you were to put H, we would still know what you meant, but we're solving for that missing dimension. So first, I would find 1/2 of 7. And you'll notice that the original problem didn't have any decimals or fractions, so you really have free choice on that. I would take 1/2 of 7, which is 3.5, or 3.5 if you want, or you could do 7/2 as an improper fraction. I like this one because now what I'm going to do, multiplication, I'm going to divide both sides by 3.5. 112 divided by 3.5 is pretty easy. It is 32 equals W, or W equals 32. And we would be able to say the height is 32, and I would look at my units and say the height is 32 feet. Now, if you had chosen to go with 7/2 as an improper fraction, you would have had to multiply both sides by the reciprocal 2/7. You would have still gotten the same answer, 32. All right. Now, I'll do the next one using the decimal only because you'll notice it already has a decimal in it, which sort of locks us into which choice we really have to use. Remember that height is often the dashed segment. It's also going to be touching that right angle. So our height and our base make a capital L or a capital T. And you can see that in this case, the base is the 18 and the height is the thing we don't know. So we're going to start with A equals 0.5 times base times height. It's really the same formula. I use the decimal because the area, 21.06, which is going to go on the left, is already a decimal, times the base, 18, times the height, x. So what is 1/2 of 18? Or 0.5 times 18 would be 9x. Here's your one-step multiplication problem, right? 9x is multiplication. So we will divide both sides by 9 and get 2.34 equals x, or x equals 2.34. And we would say the height is 2.34. And I look back up and the units are millimeters. All right. So one partial extra step in this type of problem where we have to simplify the 1/2 times some number before we can continue to solve. Now we do have this interesting sort of unique triangle where the height is not inside. Typically you would see this one out here dashed. Sometimes it is not. So I did want to show you that there is a little bit of variety depending on, say, the teacher, the professor, the textbook, but you're still looking for that right angle symbol. The height is going to be the Y, and the base has to be one of the sides. So the base is just that 0.5. So first we would write our formula. 0.75 is a decimal. So I'm going to do A equals 0.5 base times height. The area I was given was 3. 0.5 times the base is 0.75, and the height that I don't know is Y. So I would start by multiplying the numbers that are together so that I can get down to that one-step equation, 0.375y. Divide both sides by 0.375, and I would get 8 equals y. And you're going, why? This is so weird, Mrs. Fraser. Why are we getting 8? That number is so huge. Well, what you're doing is you're saying, how many times does this little tiny decimal go into a whole 3? Like if you had 0.375 of a candy bar, how many fractional candy bars would be in 3 whole candy bars? And you'd have a much bigger answer because you're saying how many of these little parts fit into these 3 big holes. So it did get larger because you were dividing by a decimal. We could also say y equals 8, and then we would look. The thing we didn't know was that pink height. So the height is 8, and I would check my units, inches. Last but not least is the trickiest one because there are no numbers in the picture at all. Notice the base and the height are both variables, but they are the same variable. The reason for that is that this is an isosceles triangle. And this is a very special case. It will come up over and over again to see if you know what to do with it. So you've got the area, and so we're going to start with that. We'll start with A equals 1/2, you can do 0.5 or the fraction 1/2, times Z times Z. And so it's like, okay, well, what do I do to simplify that? There's not even anything to multiply, right? 72 equals 1/2 times Z times Z. Well, the Z times Z could be written as Z squared. And you're like, great, that still doesn't really get me anywhere. How do I get rid of that 1/2? I'm going to multiply this side by the reciprocal 2 over 1 and multiply this side by the reciprocal 2 over 1 so I can get rid of that 1/2. So 72 times 2 is 144 equals, the only thing I have remaining here is the Z squared. And we learned when we were working on squares that the inverse of squaring is square rooting. So I'm going to square root both sides, and I'm going to get that 12 equals Z, or you can say Z equals 12, either way. And that 12 would be both 12 meters. It would be both your height and your base. So the base and the height are both 12 meters. And that isosceles triangle question comes up quite often. And if you need to, please rewatch this part of the video when you're doing that type of problem independently.